Okay guys, here's the last video lesson for Unit 9. This is our second video for 9.5. This is called Perfect Square Trinomials. So perfect square trinomials we actually sort of discussed in the last section, and that's what we're going to start with is a review of Unit 8 whenever we had what we have right here, a binomial squared. So if we have a binomial squared, you should realize that that means you're going to take this binomial x plus 7 and multiply it by itself, x plus 7, which means you will FOIL x times x is x squared, x times 7 is 7x, 7 times x is another 7x, and 7 times 7 is 49. Giving you your final answer here once you combine these two middle terms of x squared plus 14x plus 49. Now, if you remember the shortcut to this section, anytime you had a binomial squared, you could have remembered that it was going to be the first piece squared, the last piece squared. So this first piece was x squared, the last piece was 7 squared, and then the middle piece here was 2 times the first piece times the second piece, so 2 times x times 7, because it's 2 7x's as you can see here. So I'm actually going to write these down over on the right side as just a reminder. So if you need to, pause your video, copy down what I have on the right there, which I'm saying will work for either a plus b or a minus b, does not matter. You will simply square your a, square your b, and then 2 times a times b. So 2 times a times b to get that middle term. So we're going to move on to number 2. If you need to pause, pause. But for number 2 here, we're going to square our a. So 3x squared is 9x squared. We're going to square our b. Negative 4 squared is 16. And then we're going to take 2 times the a, which is 3x, times the b, which is negative 4. And that's going to create our middle piece of, what is that? Negative 24x. And there's your answer. So there was your shortcut when squaring a binomial, so that you didn't have to FOIL. You could have used this shortcut over here to instead of FOIL. Now again, the reason that's important is because we can now use those same steps in reverse to reverse FOIL these problems. So I've written down over here to the side that you need to undo these above steps. So you're going to undo what you've done up there to factor these. And I've also written, and this is extremely important here, that taking the square root is the opposite of squaring something. So let's just look at number 3 together here. If the first step up here was to square a, we're going to undo squaring a by square rooting a. Well, the square root of 25x squared is going to turn into just 5x. Square root of 25 is 5, square root of x squared is x. Pretty simple there. Then, if the second step up here was to square b, we're going to undo that by square rooting b. Square root of 9 is 3. So the square root of 9 is 3. And then the sign that goes in the middle of these is going to be whatever sign that middle term has, so in this case a negative. So you're done, and what this is factored into is this polynomial, but it's this polynomial squared, meaning that there's 2 of those binomials. It's 5x minus 3 and another 5x minus 3. Or you can just write it as 5x minus 3 quantity squared. So there you have it. There's our shortcut. That's what this section's all about, is first determining whether or not these polynomials are perfect squares, and I guess I should mention that here on the first problem, and this is actually critical, so make sure you go back and understand this. I knew that this negative 30x was the correct term because, again, you have to think about this last piece up here, which is the middle piece 2 times a times b. So is 2 times your a, your 5x, times b, which in this case is your 3, or more importantly, negative 3 that we now know because that middle sign was negative. Does this 2 times 5x times negative 3 give you that negative 30x? And it does. So let's practice this one again one more time, since I didn't really mention that real well there at the beginning. So again, we're going to undo our steps. So step 1 is to undo the square root of, or to undo 49y squared by taking the square root of 49y squared, which is 7y. Undo the last term, undo this 36 by taking the square root of 36, which is 6. And now really what we should be doing is we should be checking. This has a positive sign, so we know it's going to be a plus in the middle if this works. And we're really checking to see if this works. So in other words, we're saying, is 42y the first piece times the last piece doubled? So we're going to say, is 42y, is it 2 times 7y times 6? And yes, it is. 2 times 7y times 6. Oh, I'm sorry, no. No, 2 times 7y times 6 is 84y. So 2 times the first piece times the last piece does not give me this middle piece that they have, which means this is not the correct answer, which means I cannot shortcut this problem. Again, it does not mean that this problem cannot be factored. It just means that you'd have to go back to the old way of factoring it by taking 49 times 36. So again, since the middle piece was not the right number, you cannot use your shortcut. You've got to go back to the old way of factoring it. All right, sorry about that. Made a couple mistakes there. We'll fix them here in our next problems as we continue to practice. Okay, so our next 3 problems here, 5, 6, and 7, we're going to practice what we just learned. Are these perfect square trinomials, or are they not? And then if they are, how do we factor them? If they're not, what do we do? Then the last 3 problems are actually review problems, so we'll get to those here in a minute. Those are review problems, just kind of going over all of our methods. So, number 5 here, let's double check to see if this is a perfect square trinomial. And again, it kind of looks like it is because 4 is a perfect square, 9g squared is a perfect square. Whenever you see that, you're going to first think, well, maybe it's a perfect square trinomial. So let's double check. What's the square root of 9g squared? I'll move this down a little bit. 3g. What's the square root of 4? 2. The middle number, it's a positive. So is that middle number, is that 12g, is it 2 times 3g times 2? Well, 2 times 3g is 6g times 2 is 12g. So it is. That does work out, which means this is your answer. It's this binomial squared. All right. No mistakes there. Good. We've applied the shortcut to that problem. So, excellent. So let's move on to number 6. Let's double check. Is this a perfect square trinomial? Now, again, you might look at this and say, well, 1x squared, don't forget that 1 is a perfect square. Square root of 1 is just 1. So yes, 1x squared is a perfect square, and you might look at this and say 9 is a perfect square. But that's where we will make a mistake, because that's not a 9, it's a negative 9. And if you type the square root of negative 9 into your calculator, what are you going to get? My calculator says air. And it says air because you cannot take the square root of a negative number. And I'm going to write that down here. So you cannot take the square root of a negative number. Because think about it. square roots, the square root of 16 is 4, because 4 squared makes 16, or actually negative 4 squared makes 16, but nothing squared is going to make a negative 16. So you can't say something squared makes negative 16, because nothing squared does make negative 16, which is why you cannot take the square root of a negative number. So because of that, this is not going to be a perfect square trinomial. Does that mean sorry, does that mean that we're done? Does that mean that this problem is over? No, not necessarily. That just means that we go back to the old way of solving this problem. So I'm going to go back to my old method of solving this problem, which is to take 1 times negative 9, which gives me negative 9, and try to find factors of that and make positive 6. So 1 and 9, 3 and 3. Now again, be careful here. Make this a little neater, sorry. 1 and 9, 3 and 3. A lot of people are going to look at 3 and 3 and say 3 and 3 makes 6. Yes, but 3 and 3 will not make 9, or will not make negative 9. The only way to make a negative 9 is if one of these is negative. Well, negative 1 and 9 is not going to work. Negative 3 and 3 is not going to work. How about 1 and negative 9? No. And again, 3 and negative 3. No. So none of these work. So this does end up being a prime polynomial, meaning it cannot be factored at all. There's no way to factor this problem. Problem number 7 here. Got a mistake in the original problem. I want you to take the... Oh wait, no, that's not a mistake. It's not a mistake, but what is wrong with this is what the first thing you should be asking yourself is, what this looks wrong, and that's what I was looking at. Something's wrong about this, and what is it? Well, it's that these terms are in the wrong order, right? Well, that's fine. I'm just going to rewrite them. I'm going to say 9n squared plus 42n plus 49. Now it's in the right order. Now it looks much better. Now I can check to see if I have a perfect square trinomial, which, again, it looks like maybe I do, because both the first and the last pieces are perfect squares. So, square root of 9n squared, 3n. Square root of positive 49 is 7. Middle term has a positive sign. So again, I'm checking, is that 42n, did they get it by taking 2 times a, which is 3n, times b, which is positive 7. And 2 times 3n times positive 7 does give me 42n. So yes, this worked, which means yes, this is my answer. It's that binomial squared. Don't forget the squared part. 3n plus 7 squared, meaning 3n plus 7 times 3n plus 7. Alright, very good. Those were the last 3 problems of just this section, perfect square trinomials. What I'd like you to do now is practice the last 3 on your own, because there's some things that you need to remember about the last 3. Some tricks maybe, or just really it's just good review for the test. So go ahead and pause the video and try those last 3 on your own. Alright, and we're back. Again, I'm going to go through these just so you can see if you did them right step by step. First problem, again, since our method here of factoring is always to first check for the GCF, we're going to first check for GCF, and it's going to say 5a to the third minus 80a does have a 5a as a GCF. So I'm going to factor out that 5a, leaving me with a squared minus 16. And hopefully you guys did not say you were done now. This is all correct so far, yes, but right here you have a difference of squares. Difference of squares, a squared minus 16. So if you remember from the last section, a squared minus 16 factors into a plus 4 times a minus 4. And then don't forget about your 5a in the front. There, you're done. And again, I know I'm done because last thing I check is GCF again. There is no GCF there. There is no GCF there. So I'm done. There was no GCF here either, but that's because it was a difference of squares is how you had to factor that one. Alright, number 9. Again, first thing I'm going to check is GCF. I say there is no GCF. Alright, so I'm going to take A times C. 1 times 6 is 6. Factors of 6 to give me 5. Actually, to give me negative 5 are going to be negative 2 and negative 3. Negative 2 times negative 3 gives me positive 6. Negative 2 plus negative 3 gives me negative 5. Since this was a 1c squared, I'm going to apply my shortcut and just say my answer is c minus 2 times c minus 3. Done. Again, I know I'm done because I checked GCF last, or I look at these pieces, I say there's nothing that can happen to that, nothing that can happen to that, so I'm done. Alright, last problem. Again, always first step, GCF. Is there a GCF here? 8, 18, and 35? No, nothing there. X squared, X, and then no X's, nothing there, so no GCF. Which means this one's going to be a big one. This one's going to be one of those long ones. I'm going to have to take 8 times negative 35, which gives me negative 280. So kind of a big number here. It's alright. We'll get through it. And we need to find two numbers that make negative 18. Well, right off the bat, that's going to be good to see because those numbers seem easy, and they are, because to get negative 280, 10 times 28, which 10 times 28 are 18 apart, so now you just got to figure out which one gets which sign. And again, it'll be positive 10 and negative 28. Multiplying those together would give me negative 280. Adding them together would give me negative 18. Alright, so that wasn't too bad. Going to plug this in the middle. 8x squared plus 10x minus 18x minus 35. The reason I plug them in the middle is so that I can now group factor. Out of the first group, I'm going to factor out a 2x, leaving me with 4x plus 5. Out of the second group, what's going to come out of there? It looks like a and that's why I'm having problems. I realized that this number here was wrong. That number should have been a negative 28, not negative 18. Negative 28x, which definitely changes what I factor out of that group. So now, factoring out from negative 28 and negative 35 is a negative 7. Much easier to do if you have the right number there. Factor out a negative 7 leaves me with 4x plus 5, which then shows me my correct final answer. 2x minus 7 and 4x plus 5. Alright, done. And again, that was just a little review of the other types of factoring methods we need to know. Okay, now these last three problems will also be a review of what the new stuff we learned. So we are going to be double checking for perfect square trinomials, but we're also going to learn a little trick on how to solve perfect square trinomials. So let's look at the first problem here, and we're going to say, okay, right off the bat, 25d squared and positive 1, they look like they have, they look like perfect squares, or they are perfect squares. So let's check to see if this is a perfect square trinomial. Square root of 25d squared is 5d. I'll move that down a little bit. Square root of positive 1 is 1. The middle number has a negative sign, so this would be a minus 1. So now let's check this. Is this negative 10d 2 times 5d times negative 1? Well, 2 times 5d is 10d times negative 1 is negative 10d. So yes, that does work. So that means yes, this is the factored form of the problem. But remember, this is an equals 0 problem, so we're not done. We now have to solve. Now, the old way we'd solve this is we'd say, okay, I have 5d minus 1 times 5d minus 1 equals 0, and you'd say 5d minus 1 equals 0, 5d minus 1 equals 0, and then you'd solve. So you're going to get d equals 1/5. And over here you're going to say, you're going to get the same thing. D equals 1/5. Now, there's something new we can learn, or something new we can do right here. And this is kind of based on what we learned earlier, where we talked about how taking the square root is the opposite of squaring. So right here where I have 5d minus 1 squared equals 0, what I can now actually do is, just like adding or subtracting something from both sides, I can actually square root both sides. The square root of this left side, the square and the square root just cancel each other out, leaving you with 5d minus 1, and the square root of 0 is just 0. So now you just solve this problem once and get d equals 1/5, which again, if both answers are 1/5, you only need to write it once. So you can square root both sides to solve a problem now too, just like you can divide both sides by something or add something to both sides, you can square root both sides. So just a little time saver there, nothing major. Okay, so these last two problems, same as the first one, just slight variations. The first one, the slight variation is obviously that we have fractions to deal with. And we're going to do this story problem in class together, so we're just going to erase it, give you more room to work. So, number 12, again, fractions can be perfect squares too. So when we're looking at this one and I'm saying 1y squared, that's a perfect square. 1/9 is also a perfect square because both 1 and 9 are perfect squares. So yes, this might be a perfect square trinomial. Again, not 100% sure yet. We'll have to double check. Let's double check. Square root of 1y squared is just y squared. Square root of 1/9, you actually do, like I have up here, as the square root of 1 over the square root of 9. Well, the square root of 1 is 1, square root of 9 is 3, so you get 1/3. And that's how you do any square roots of fractions right there. Just square root of the top number over square root of the bottom number. Now we got to double check though. Is this middle number, is that 2 times the first number times the last number? The 2 times a, and in this case a was y. So 2 times y times 3. Oh, that leads me into a mistake of mine. Square root of y squared is not y squared. I'm making lots of mistakes today. Square root of y squared is not y squared, it's just y. Sorry about that. So this first term here is just y. So 2 times y times 1/3. Okay. 2 times y times 1/3. What is that going to give me? Well, that'd give me 2y times 1/3, and 2y times 1/3 is 2/3 y. So yes, that does check out. Negative 2/3 y, just meaning my middle sign's negative. So yes, this does turn into y minus 1/3 squared equals 0. Let's apply our new method of solving here by undoing a square by square rooting both sides. Gives me y minus 1/3 equals 0. makes solving much easier. Add 1/3 to both sides, and you get y equals 1/3. Done. So, not too difficult. Don't make those mistakes I made, but or if you do, make sure you catch yourself like I have been. So y equals 1/3 for that one. Last problem, a couple little slight variations here. Again, got to make this equal to 0, so I'm going to add 4 to both sides. 16n squared plus 16n plus 4 equals 0. Again, not forgetting that you should always check for GCF first. I see that the GCF there is 4, leaving me with 4n squared plus 4n plus 1. Now again, you don't have to use this shortcut, but I'm looking here and saying, hey, this might be a perfect square trinomial, so can I shortcut it? Well, let's see. What's the square root of 4n squared? 2n. What's the square root of 1? 1. Middle sign is a positive. So is that middle number the right number? Is 4n 2 times 2n times 1? And yes, 2 times 2n times 1 is 4n, so that is correct. So this is my binomial squared, but I'm going to write it as 2n plus 1 squared equals 0, and then I'll use my new solving method, square root both sides. 2n plus 1 equals 0, and then I'm going to skip the basic solving steps, and you should know that n equals negative 1/2 in this case. So there you have it. Just a couple new tricks, new things you should learn about math. Undoing a square is square rooting, and you can use that to help you solve some problems. So that's it, and we will move on to the homework.